I'm hoping everybody can hear this video. There is sound with it, so please make adjustments to your computer, hopefully. People who see this can do that so they can hear me. We are in the Chapter 2 study guide for geometry. This is the lesson on Chapter 2, Section 1, Part 1, otherwise known as 211. A conjecture is a guess based on observation. So, as human beings, we experience a lot of different things, and we can kind of learn from the observations that we have in our lives. And so conjecture is basically something that we are kind of figuring out is probably something that's true based on what we've seen. Inductive reasoning is a thinking pattern where we're kind of putting all these observations together and we're saying, hey, I'm seeing a pattern. And from that pattern, I'm going to make a conclusion about what I think is probably true. So, in this section we're going to be looking at patterns of pictures and patterns of numbers, and we're going to be trying to figure out any trends that we see. So, for example, if I have figure 1, do you see how it has 2 pieces and the bottom is shaded in? Figure 2 has 4 pieces and the bottom left-hand corner is shaded in. Figure 3 has 6 pieces and again the bottom left-hand corner is shaded in. If I were to draw figure 4, well, figure 1 has 2 parts, figure 2 has 4 parts, figure 3 has 6 parts. So do you see how if the figure number is multiplied by 2, it tells me how many parts it has? 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So if I were to try to draw the 5th figure, I know that that would have twice as many parts. The 5th figure has 10 parts. So obviously I'm drawing it a little bit larger, but I'm trying to make sure there's 10 parts. 1, 2, 3, 4, 5 sections vertically, and then if you chop each one of those in half horizontally, there you go. Now, I'm not the best sketch artist, but good enough, huh? And then it looks like whatever the figure is in the bottom left-hand corner, that gets shaded in. So my guess would be that that is the figure that would be the 5th one in this sequence, based on what I've observed in the first 3. You could call this my conjecture, based on my inductive reasoning. Okay, how about this one? Looks like I've got a big rectangle. Rectangle here and a rectangle here. The large outside shape is always a rectangle. Then inside I've got an arrow pointing to the right on this one. Got an arrow pointing up on this one. And I've got an arrow pointing to the left on this one. So I'm going to guess that it's kind of rotating around. It's going right, up, left, and my guess would be that the next figure in this pattern would have an arrow pointing down. So it looks like we're going from the halfway mark. I'm going to basically do it like this one, just upside down. And then the sides of the arrowed portion, on the side that it's touching, is shaded in. So I'm going to shade in these 2. And that's the next figure based on what I've seen, as the arrow rotates around. Number patterns. Describe the pattern in the numbers -1, -4, -16, -64. Well, they're basically trying to tell you that the next number in the sequence is 4 times as big as the other previous numbers, or the other previous number. So if you take -1 and you multiply it by 4, you get -4. Take -4 and you multiply it by 4, you get -16. If you take -16 and multiply it by 4, you get -64, and so on. So they would like for us to figure out what the next 4 numbers are. Okay, if I take -64 and multiply it by 4, following the same pattern, I get -256. And if I take -256 and I multiply it by 4, I get -1024. And if I take -1024 and I multiply it by 4, I get -4096. So my answers are, the next 3 numbers would be -256, -1024, and -4096. Okay. Example number 3. Well, it looks like they put a dot. Number of connections, well, it's not connected to anything, so that would be 0. And they put 2 dots. It looks like they connected it. So how many connections do I have? Well, just 1 connecting line, so I'm going to say 1. And they put 3 dots. And how many connections do I have? 1, 2, 3 connections that have been drawn in, so I'm going to say 3. And then put 4 dots. And then how many connections can you make between any 4 dots? 1, 2, 3, 4, 5, 6 connecting lines. And then with 5 dots, how many connections can you make? Wow, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can make 10 connecting lines between 5 points. So how are these numbers increasing? Well, to go from 0 to 1, it says we could add, well, add 1. To go from 1 to 3, how much would we add? We would add 2. To go from 3 to 6, how much would we add? We would add 3. To go from 6 to 10, how much would we add? We would add 4. So, the question is, if you can connect 6 points in all the ways that they can be connected, how many different ways would that be? How many little lines, connecting lines, would we have? So, if we were to make 6 points and then connect them all, wow. Well, rather than drawing the points and connecting them all, what we could do is simply look at the pattern as the numbers progress in the bottom. The number of connections has this pattern. Every next number is following a pattern of increasing numbers of connections. So as you can see, we added another connection here, 2 connections there, 3 connections there, 4 connections there. So to go from figure 5 to figure 6, it seems to me like we would add another 5 connections, which means that 10 plus 5, we would have 15 connecting lines between 6 different points. And I did that by just taking 10 plus 5. Okay, now these are actually kind of hard. Once we kind of take away all the helping things, we take away all the pictures and we take away all these little suggestions where this one tells you that you're adding stuff and this one tells you that you're multiplying, and we just kind of give you a table of numbers. This can be hard. There's many different ways to approach these. Some of them would be, oh, I'm subtracting 1 each time, but that doesn't always work, because there's 2 rows of numbers here, not just 1 row that we're trying to find the pattern in. So sometimes when you look at these the first time, you're not going to come up with the relationship right away. So after I looked at this for a while, the pattern that I saw was actually a connection between the x and the y. I saw that if I added the x plus the y, I always got 5. 1 plus 4 is 5. 2 plus 3 is 5. 3 plus 2 is 5. So, if I were to draw a rule for the relationship, I would say that x plus y equals 5. Now they didn't say write an equation or a linear equation, so I would say that this kind of rule is okay. Now if they did ask you for a linear equation or a function, you couldn't write it this way because equations are written y equals and then everything else on the other side. So what I would do is, if I had to write it the other way, I would subtract x on both sides, canceling it here, getting my y by itself, and then on the right side I would have 5 minus x. It's the same relationship. It gives you the same truth, but it's just written in two different ways. This is more formal, like a function, and this is more informal, just stating what we basically see on the page.